This lesson is going to be looking at solving systems of equations by graphing. Remember when we had two linear equations in a system, that the point that was our solution when we graphed them was the point where the two lines intersected. So if we were looking for a solution in this graph, it would be -2, -2, because our intersection point is there. But sometimes when we have systems of equations, they're not necessarily all just linear. So if we're taking a look at this particular system of equations, one is linear and one is quadratic. So the linear equation, y equals 2x plus 1, is written in slope-intercept form. So my intercept is 1, and then my slope is 2, so that means I'm going 2 up and 1 over. And then to get the ones on the left, I'm going 2 down and 1 to the left. So then I want to, as straight as possible, connect my points. And then I want to graph my quadratic. Now, that is a basic translation of the original parent function, y equals x squared, 1 unit up. So instead of the vertex being 0, 0, it's going to be 0, 1. And then I would graph it as if it was x squared. So 1 squared would be 1. 2 squared is 4. 3 squared is 9. And then I would use the axis of symmetry to mirror it. So if that's 1 to the right, I have 1 to the left. If this is 2 to the right, I have 1, 2 to the left. And if this is 3 to the right, I have 1 that's 3 to the left. So my system of equations would look like that. Now remember, the downfall of graphing is that if you don't draw exactly straight, it's very hard to tell where your lines actually intersect each other. So I have an intersection point here, and I have an intersection point there. So my solution is 0, 1, and I have 1, 2, 1, 2, 3, 4, 5, 2, 5. Those would be my solutions to that system of equations, because the graphs would intersect each other twice. Then let's take a look at this one. This time we have a linear equation and we have an exponential equation. So if we're looking at the linear equation, that one's the easiest to graph. That's x minus 1. The intercept is -1, and then my slope is 1. So it's up 1 over 1 every single time. And then to get the ones on the left, it's down 1 over 1 to the left. Okay, and then we have our exponential function, which is y equals 3 to the x power minus 2. So for that one, if I make a value or a table of values, I have my x and my y, and then we'll just go -3, -2, -1, 0, 1, 2, and 3, right? If I substitute in, I would have 3 to the -3rd power. That equals 1/27th, and then 1/27th minus 2, right, would be -1 and 26/27. Then if I put in a -2 in there, I would have 3 to the -2 power is 1/9, and 1/9 minus 2 would be -1 and 8/9. Put in a -1, I get 1/3 minus 2, which would be -1 and 2/3. If I put in a 0, 3 to the 0 power is 1, minus 2 is -1. If I put in a 1, the first power is 3, minus 2 is 1. If I put in a 2, 3 squared is 9. 9 minus 2 is 7. And if I put in a 3, 3 to the third power is 27. Minus 2 gives me 25. And that value wouldn't fit on the graph. So, as we can tell, our value here is going to get exponentially close to negative 2, which is where the minus 2 comes from. So if I have negative 3, that is almost negative 2. Then negative 1 is almost negative 2. Negative 2 is almost negative 2. 0 is at negative 1. 1 is at 1. 2 is at 7. And then 3 is at 25. So the graph of the exponential function goes exponentially close to negative 2, and then it comes up drastically fast that way. So we have one solution to our equation, and our solution in this case would be 0, negative 1.